As shown above, a 0.2 kilogram mass is sliding on a horizontal frictionless air track with a speed of 3 meters per second when it instantaneously hits and sticks to a 1.3 kilogram mass initially at rest on the track. The 1.3 kilogram mass is connected to one end of a massless spring, which has a spring constant of 100 newtons per meter. The other end of the spring is fixed. A. Determine the following for the 0.2 kilogram mass immediately before the impact. First bit, its linear momentum. Second bit, its kinetic energy. B bit. Determine the following for the combined masses immediately after the impact. First bit, the linear momentum. Second bit, the kinetic energy. After the collision, the two masses undergo simple harmonic motion about their position at impact. C bit. Determine the amplitude of the harmonic motion. D bit. Determine the period of the harmonic motion. Here, a mass of 0.2 kilograms slides on a horizontal frictionless air track and hits another mass of 1.3 kilograms, which is attached to a spring whose spring constant is 100 newtons per meter. Here we have to find out the initial momentum of the block, which is sliding, and the kinetic energy of that block. And after hitting the second block, we have to find out the final momentum and kinetic energy of the system. And after hitting the block, both the blocks are attached to the spring, and then the entire system acts as a simple harmonic oscillator. For this simple harmonic oscillator, we have to find out the amplitude and the period of the oscillations. Okay. Now let us see what is the momentum of the first block, which is sliding with a velocity of 3 meters per second. So mass is 0.2 kilograms and velocity is 3 meters per second. As we know, momentum is equal to mass times velocity. The momentum, initial momentum of the block is 0.6 kilogram meter per second. Next, we have to find out the kinetic energy of the block. So kinetic energy is equal to half mv square. Therefore, K is equal to kinetic energy K is equal to 0.9 joules. Next, the block hits another block of mass 1.3 kilograms. We have to find out the momentum and the kinetic energy of both the blocks. Okay, the first block hits the second block and then sticks to the second block. So we have to find out the momentum and the kinetic energy of the combined system. So to find out the momentum, we need velocity. So using the law of conservation of momentum, we will find out the velocity of both the blocks. So therefore, according to law of conservation of momentum, the momentum before collision is equal to momentum after collision. Therefore, we already found out the momentum before collision, which is 0.6 kilogram meter per second, is the same same after the collision also. From this, we will find out the final velocity. Therefore, P is equal to mv, and then which is equal to 0.6 kilogram meter per second, and then mass is total mass, 0.2 kilograms plus 1.3 kilograms. We have to take the total mass of the system. That is equal to 1.5 kilograms, and velocity is equal to 0.6 kilogram meter per second divided by 1.5 kilograms, that is equal to 0.4 meters per second. Now kinetic energy is equal to half mv square. Now velocity we found out, and then mass is 1.5 kilograms. Therefore, plugging the values in the equation, we will get kinetic energy is equal to 0.12 joules. Next, we have to find out the amplitude of the simple harmonic motion. So to find out the amplitude of the simple harmonic oscillator, we need the this one. X, we will use the conservation of energy to find out the amplitude. How to find out that one? First, the blocks have the kinetic energy. The first block has the kinetic energy, that is the initial energy of the system. And then the final energy is because these two blocks are attached to the spring, and then these blocks, after once the first block hits the second block and then attaches itself to the second block, then it pushes the spring. That means a kind of compression takes place in the spring. That compression, because of that compression, the spring mass system becomes the simple harmonic oscillator, and then oscillator, they start vibrating or oscillating. Therefore, here the initial energy, which is the kinetic energy, gets converted into elastic potential energy. The spring has elasticity, therefore the energy gets converted into elastic potential energy. The spring gets compressed. So work is done on the spring. That work is stored in the form of energy, that is the elastic potential energy. Therefore, according to law of conservation of energy, the entire initial energy is equal to final energy, or the entire kinetic energy gets converted into elastic potential energy. Therefore, K is equal to U spring, and then kinetic energy is equal to half mv square, and then the elastic potential energy is half kx square. Here we have to find out the x, that is the compression in the spring. So that is equal to 0.05 meters. Okay, using this equation. Next, we have to find out the time period of the harmonic oscillator. Okay, so the time period t is equal to 2 pi root m by k, and then plug in the values. M is equal to total mass, 0.2 plus 1.3 is equal to 1.5 kilograms, and k is equal to 100 Newton per meter. Therefore, t is equal to 2 pi square root of 1.5 divided by 100 is equal to 0.77 seconds is the time period of the simple harmonic oscillator. Okay, so this is an multiple concept question. It involves the involving the collisions and then the energy and then simple harmonic motion. Here you are finding out the momentum, kinetic energy, and then the amplitude and time period. Okay, these many things. Unless you are thorough with all these concepts, you can't solve this problem. Hope this helps. Thank you. Bye bye.